Hello. So today we're going to learn about understanding docking and what information can we get from docking. I won't go in details of docking, but we have different platforms of docking. One of the platform is you can use SwissDock as here, and after you use SwissDock, you can always download the docked file. You can also use and in SwissDock what you just need is you need I usually go with this one. You just need the smiles of the ligand. For example, we are studying D-Hydroxyphenyl Hydantoin docking with D-Hydantoinase. So from PubChem you can get the smiles, and it is these smiles that you put in here. For example, this is the smiles of the, and then you prepare a ligand here, and also you can download the file, protein file, which is the receptor from Uniprot or from PDB, and getting a PDB from there, from the database, you can just here choose the file, and on choosing I created a folder of D-Hydantoinase engineering, and here I get the PDB version, and just selecting. Before docking we need to prepare this and this, and when it brings a tick, it means it's okay. And this is where we can visualize. It creates a box, but the disadvantage of SwissDock is that the box is limited, that when you keep adjusting it cannot go further. So assuming we leave these dimensions by default, we shall just check parameters. You can also adjust this exclusiveness, which means the number of times the system runs over. You can actually use 16 or 8, and then you change, you check parameters. So you start docking, and the result is that I showed you. Okay, when you start docking you will see. Another platform that we can use is called SimDock. You can just write SimDock, see, SimDock, and in SimDock I usually get it from here, from this university. It's Paris University, and from here you can read about how it works, and finally we can use this tab to run dock. So ideally you don't need to download the docking platforms, but if you really want to understand the basics of docking, if your computer is so strong, you can here it brings again, you can put SDF file again from the PDB, because the PDB gives you options. You should not download the 2D, but in docking we use 3D only, because it's more accurate, and it takes into considerations of tetrahedral angles of the substrate, and you can see the SDF is here, and it's what you can use here, or you can use the mol2. You can get the mol2 files from another platform called the molview, and from the molview you can always you can always type here in the search bar. I'm looking for hydroxyphenyl Hydantoin, any compound, as long as it's it's characterized in the PDB, no, in the PubChem. It will always be here in the mole view, because in the mole view we can actually get structures from PubChem or any. You can import actually. Yeah, you can see PubChem structures. So this is the structure that I'm looking for. I'm specifically looking for the para, but I don't know why this one is not hydroxy. Maybe I chose wrongly. It should be hydroxyphenyl, P-hydroxyphenyl. So we should take caution of that. Let me see. Okay, it is here, hydroxyphenyl Hydantoin. This is what I was looking for, the hydroxy group at position P. This is the para metal, like that. So I'm looking for the para, and after getting this, you can always download this mole tool. If it is 2D, you can convert to 3D, and by downloading, you press here. After downloading, it's what you can also use here, or you can also use the smiles of the structure. As I showed you here, you just use the PDB file and then we'll launch dock. After docking, results will appear here, and you can always use them after the docking is done.